Okay, so before we start, just so we uh make sure, just on your computer, go to the discussion course page and then go to the quiz tab. Do you all see the quiz posted there? It's not open yet, but it should be posted there. Do you all see it? So that way, like at 8:30, I just end it, and then you just, you're in that tab already, and then you just hit the quiz, and then you start. Okay, cool. So let's get started. So again, we define the integral, right? We're going to define the integral as that limit of the Riemann sum. And f of xi delta x, right? Where delta x is b minus a over n, and xi is a plus I delta x. Yes, so we have like certain properties of the integral, right? So this is called the integral. If you integrate backwards, it's the negative, right? So if you integrate from a to b and you go from b to a, it's pretty clear. It's, you're going backwards, right? So it's negative. And if you integrate from a to a, well, what is this? This is the area under the curve of f at a point. Yeah, at a point, no matter what rectangle you choose, it will have no width, right? Because your delta x is 0. It's a minus a over n, right? There's no width. So this should be 0, right? And hopefully you all know what I mean by this. But so here, when I write this, I mean that, if it's plus on the left, it's plus on the right. And then if it's minus on the left, it's minus on the right. So plus minus, just to save some space. For those who came in, just quickly go to the discussion course space and go to the quiz tab. So you're ready when it's like 9:30. Okay. Now, this last one is, you could do it, you could just memorize it, or you could think about what this means, right? This is just the constant function c. So if you have the function y equals c, and you're integrating from a to b, well, the area under this thing is just a rectangle, right? It has height c and width b minus a, right? So area is length times width, so it's c times b minus a. And the last one, it's not as intuitive. Like the proof is like case by case basis, but let me sort of explain the easy case at least, so you're all convinced. So this is for all ABC, yeah. But I think the easiest to see is when A is less than B less than C. Yeah, because if F is like this, right? And this should be straight. If here is A, here is B, here is C, right? What is integral A to B? Integral A to B is the area here, right? And integral B to C is the area here. So they're just saying the area from A to B plus the area from B to C is just the area from A to C. So hopefully that's intuitive. Okay, so how would you, now the question is, how would you evaluate these integrals, right? And the idea here is FTC. So, okay. So FTC, so the actual word is fundamental theorem. THM is theorem. of calculus, right? Most books just call this FTC. So there's a part 1 and part 2. So to understand part 1, you have to understand what this means, right? So if I write g of, I'll leave this blank for now. G of whatever is integral a to x f of t dt. Yeah, my first question would be, is g a function of x or a function of t? So this is the first thing Math 2B students get confused with. It's a function of x, right? Because if it's a function of t, if I plug in g of 1, if it was a function of t, it would be f of 1 d1, right? To be honest, I don't know what d1 means. So this is g of x, yeah? So this is sort of like area under the curve from like a to whatever point you plug in. So if I set a to be, let's say a is the number 0 to make things simple. And I have, let's say, a trapezoid. Let's do 2, this is 3, this is 0, yeah? Let's sort of understand what this function is, yeah? So what is g of 0, g of 1, g of 2, g of 3? So g of 0 is integral 0 to 0 f of t dt. Oh, sorry, this is f. That's the graph of f. So what is this? What is integral 0 to 0 f of t dt? Yeah, 0, right? It's that rule I told you, right? Integral a to a is just 0. This is 0. Now this is integral 0 to 1 f of t dt. So this is area under the curve of f, the basic area under f from 0 to 1. So it's area of this triangle. Sorry, let me give you a point. Let's say this is 2. So what's the area here? Yeah, 1/2 base times height, right? It's height 2, base is 1. So this is 1. This is integral from 0 to 2 f of t dt. So this is area of the triangle, right? Because the triangle is 0 to 1, and then you go 1 to 2, right? So the area of this rectangle is 2. So 2 plus 1 is 3. Agree? So the green part's area 2, the blue part's area 1. So it's 3. And hopefully you could see that, this thing, you're adding in the area of the red part, right? Which is by symmetry, you should get it's also 1, right? So 4. Is everyone good with this? Does everyone understand like what this function does? What g does? Okay. So let me just, like I said, right, this integral is like antiderivative, right? So if we think of, g of x, if we think of this thing as like antiderivative, this is, not equal, but let me just say is antiderivative of f. Yeah, I put it in quotes, right? It's not like definition or anything. It's a way to think of it. So what can you say about g prime? So I'm taking derivative of g, right? So if g is antiderivative of f, then this is derivative of antiderivative of f. So what do you think this is? If antiderivative is the opposite of derivative, what do you think will happen if I do derivative of antiderivative? I mean, like, what's your guess? If these are like opposites, cancels out, right? So you should be left with, in a sense, you should be left with f, right? Everyone agree? That's intuitively what should happen, and that's basically what FTC1 is. So FTC1 says just that, but formally. FTC part one. So if f continuous on AB, then function g defined by g of x integral a to x f of t dt, where a is between, here. It's continuous on AB, it's differentiable, right? It has to be differentiable for me to write the g prime, right? On AB, and like you all just said, right? And g prime of x is f of x, yeah? So when I take derivative, I should get f back because it should cancel out with the antiderivative, right? So let's just do a clear example, right? If g of x is integral 1 to x, ln of 1 plus t squared dt, what is g prime of x? So again, this is like your f of t. Sorry, I don't know why I wrote that twice. So that's like your f of t. Think of this as like, whoa, not eraser. Think of, this thing like your a. So what does this theorem tell you? What is g prime of x? Not t squared. It's f of x, right? It's no longer f of t. So it's you plug in x for t pretty much, right? So it's ln 1 plus x squared. All agree? So this is an example of FTC1, right? You just plug in the x, right? So let me just sort of tell you that, this is kind of strong in a way. So let me just give you FTC2 and sort of tell you why, right? FTC2, it's just integral a to b. It's capital F evaluated, capital F of x evaluated at a and b. And this is just notation for f of b minus f of a. Where, now what is capital F? Where f is any antiderivative of f, yeah? i.e. F prime is f. So remember, antiderivative was a family, right? So you had the plus c. So the fact you could choose any, right? I mean, unless you're in Massachusetts, you might as well just choose c as 0, right? So so that's what most people do. We just take the antiderivative, where c is 0. But this is strong, right? Because what I'm telling you is, here you didn't need to know the antiderivative, right? So if you did, you would get the same answer. So let me just do an example, right? If g of x is t squared dt, right? Then g prime by FTC1, this is just x squared. Agree? You just plug in the x for t. Kind of like here, right? I plugged in the x for t. But here you could also go to FTC2, right? What is the antiderivative of t squared? So derivative of what gives t squared? Yeah, so you can actually solve this explicitly, right? This t cubed over 3 at 1 and x, right? So my like a sort of functions as the 1, my b is like the x. So this is x cubed over 3 minus 1 over 3, right? I mean, all I did was just write this out. So now this is g of x. Now g prime of x is 3x squared over 3 minus 0, right? Because derivative of 1/3 is 0. So this is just x squared. And you see, like, you get the same answer, right? But what's the power of FTC1 in this case? You didn't need to know antiderivative of t squared, right? Like kind of like this. To answer this question, you didn't need to know antiderivative of ln of 1 plus t squared, right? To solve this question. I mean, if you did, you know, you could do that process, right? You could do antiderivative first and then do derivative, right? But this is, it's sort of redundant because they cancel out, right? So that's sort of why FTC1 is pretty useful, right? It's the fact that you don't need to know what the antiderivative is to find the derivative. Okay, everyone clear on that? Yes, no. Okay, so okay, so now let's cover, I'll go more into FTC2 next time, but for FTC1, we'll go over the 2 other cases you'll meet on like WebAssign and like homework. So the first case, right, I guess that was the first case, so case 2, it's what if, instead of x, I have an x squared. So let me do the slow way, right? I mean, the slow way is actually like show work way, slow way, the show work way. So what I'm going to do, the issue is I can't use FTC1. FTC1 only works when x is on the top, right? Not x squared. Yeah, I mean, to apply a theorem, you need everything set to be satisfied, right? So what I'm going to do is I'm going to let f of x be exactly what I want, right? The one with the actual x on top. So this one, do you all agree I could apply FTC part 1, right? I just plug in the x for t, right? Now, I'm going to let h of x be the thing I replace, right? So x squared. Can anyone tell me what f of h of x is? Is it true or false that this is just g? I'll ask it that way. Is this just g of x? So this is function composition. This is math 2a, but it's actually quite simple. The best way I can explain this, if you forgot, is yeah, it is g, yeah, but okay, hopefully this will make things clear, right? What is f of 2? You would say integral 1 to 2 of this thing. Agree? So what did you do? You plugged in 2 for x. Agree? So f of h of x is the same exact thing, right? The h of x serves the role as 2. So instead of plugging in 2 for x, you're plugging in h of x for x. Everyone agree? So this is exactly g, right? This is because h of x is x squared. So it's exactly this thing. Everyone good? So now the question is, right? The question is find g prime, right? So g prime, to find g prime, it means take derivative of the right-hand side. But since they're equal, that's the same as taking derivative of the left-hand side. And if you remember from math 2a, this is chain rule. Yeah, when you take derivative of a composition, this is f prime of h of x times h prime of x. Do you all remember this? Do you all remember chain rule? Okay, so we're almost done. So let's find, so to find f prime of h of x first, let's do baby steps. What is f prime of x? So note f was this. F has the x on top. So I can use FTC1 now, right? There's only an x on top now. So what is f prime of x using FTC part 1? Good. So what's f prime of h of x? I mean, again, if this looks scary to you, just do this. What's f prime of 2? ln of 1 plus 2 squared, right? What did you do? You plugged in 2 for x. Agree? So f prime of h of x is you plug in h of x for x, right? And since h of x was x squared, this is ln of 1 plus x to the 4th, right? Everyone good? And hopefully by now you know h prime of x is 2x, right? Derivative, I trust you all know derivative of x squared. So this thing is ln of 1 plus x to the 4th times 2x. Yeah, so that's a slow way. The fast way is plug in and multiply by derivative of what you plugged in. Right? So if I plugged in x squared, I get 1 plus x to the 4th, and then I multiply by derivative of x squared. That's the fast way. Yeah. But the reasoning is the slow way. The reasoning is chain rule. Yeah. Everyone good on this? So we're going to do the last case. So if you notice the number, what if there's not a number on bottom, right? So before I continue, let me, hopefully you see by now, the number 1 does not affect anything, right? Like I could have had a 2 and I get the same answer, right? Because if you go back to this example right here, did the 1 play any effect, right? Because let's see what the 1 did, right? The 1, I get a 1/3. But then when I take derivative, it goes away, right? So hopefully you see that if I had a 2 on the bottom, I still get the same answer, right? Because here, if I had a 2, it would be 2 cubed over 3, which is 8 over 3, but that doesn't matter, right? Because when I take derivative, it goes away. So you see, you can have any number, but now the issue is, what if I don't have a number? G of x is integral x squared to x cubed. So now you know what to do if there's a variable, right? But the problem is, you know what to do if there's a function on top and a number on bottom. So here, there's no number. So what are we going to do? Well, do you remember I told you this formula, right? And this holds for all ABC. So what I'm saying is we're going to work with the left, the right. So this sort of serves the role as your A, and this sort of serves the role as your C, right? So I can say G of x is integral. My A is x squared, and I'm going to make a number, right? I'm going to let B be 0. You don't need to be, right? It could be 1. Like I said, the number doesn't matter. Ln 1 plus t squared dt plus, and then my B, right, is this, is 0, and then this is my C, right? Now we are sort of in business, right? So this one, you all know how to do. Agree? Plug in x cubed, take derivative of x cubed, right? This one is a bit different, right? Because we need function on top, number on bottom. So how do we do that? Well, it's that property I told you, right? Integral a to b of f is negative integral b to a of f, right? If you integrate the other way, it's just negative sign. So it's 0 to x squared dt. So this is G. So now G prime is, hopefully you know what to do by now, right? Plug in x squared, 1 plus x to the 4th, times, so that we're doing it the fast way, times derivative of x squared, plus plug in x cubed. So what do you get? X to the 6 times derivative of x cubed. And this is your answer. Does everyone follow? Okay, yes, so that should cover all the things you need for your homework, I guess. Yeah, I mean, these are pretty much the three cases, right? Um, so let me go back and ask you a question now. Now that you know FTC1, can anyone tell me what G prime of 1 is? Right? So G is this, F is this. What's G, what is G prime of 1? Yeah, 2, yeah. So how do you get that? Well, if you just look at this equation right here, what is G prime of X using FTC1? You just plug in X for T, right? Right, kind of like the ln thing. You plug in X for T. So same thing here. This is F of X. Agree? So G prime of 1 is F of 1. And F of 1, if you just look, it's 2. Yeah. So similar, like G prime of 3 is 0. Now this should be parenthesis. Right? So don't like if I ask you like G prime of like 1.5, right? This is 2, right? So what I'm saying is I know like G prime, why is this wrong? Can anyone tell me? Like if I say G prime of 1.5 is, if someone says this is 0 because this is slope 0. Yeah, because derivative is slope, right? And the slope here is clearly 0. It's a horizontal line. So why is this wrong? So what's the reason for that? If someone says this is equals 0, so why is this wrong? Yeah, 0, this is F prime of 1.5, right? That's the slope of, if this was the graph of G, it would be correct, right? But the graph right now is the graph of F. So you have to understand that like this is the F prime of 1.5 is 0, right? But the G prime of 1.5 is not, right? So because this is the graph of F, not the graph of G. Yeah. So okay. Okay, so it's time. So let me just say, if you are done, just don't leave. Just, if you are done, just close your webcam and then just find something else to do. So it's because I don't know if you're, because what if you close your webcam and then like and then like you're actually not done, right? So so only close your webcam like once you're done. Yeah, and then you could leave at like 9:50. So yeah, turn all your webcams on and then you could take the quiz.